Welcome to lesson 6.4, prove triangles similar by angle similarity postulate, which we can shorten to AA. So we're proving triangles similar by angle similarity. So our postulate that we're using for this lesson, postulate 22, is known as the angle or AA similarity postulate. And what that postulate states is if two angles of one triangle are congruent to two angles of another triangle, then those two triangles are similar. So if we look at our two triangles here, angle K was congruent to angle Y. We know that because of the single arc. Angle J with the double arc is congruent to angle X with the double arc. So then we can say triangle JKL is similar to triangle XYZ. So let's look at that postulate. Example 1 says determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. So let's look at what we're given. We have triangles CDE here with a right angle of 90 degrees and the angle C being 26. So we're missing angle E. And then on triangle HGK here, we have our 90-degree angle. H is 64, we're missing K. So what I want to do is on one of the two triangles, I want to find my missing angle. So we'll use triangle CDE. So I know triangles add up to 180 degrees. So if I take away from 180 the 26 degrees for angle C and the 90 degrees for angle D, I'm left with the measure of angle E. So 180 minus the 116 here gives me 64 degrees for angle E. So I already knew angle D was congruent to angle G because they're both right angles. Now I know angle H is congruent to angle E because they're both 64 degrees. So I have my two angles. So then I can write my similarity statement. Triangle CDE is similar to KGH. And we have to match up the corresponding vertices. So C corresponds with K, D corresponds with G, and E corresponds with H. And our explanation would be the angle similarity postulate. So now in example 2, parts A and B, they want us to show the two triangles are similar. So triangle ABE and triangle ACD. So if I look at ABE on top, I know angle B was 52 degrees. And then triangle ACD, the bigger one, angle C was also 52 degrees. So we know the measure angle B is congruent to the measure of angle C. Both triangles share angle A at the top here. So we know angle A is congruent to itself. So now we have two angles on the triangles. So triangle ABE is similar to ACD by the angle similarity postulate. Now in B, we have triangle SVR here on the left and triangle UVT here on the right. So what we want to realize right away is we have a vertical angle here in the middle. Angle SVR and angle UVT are congruent because all vertical angles are congruent. Then we also were given that SR here and TU here are parallel. I know they're parallel because they each have this little arrow on their segments. So we know segment RS is parallel to TU. So that allows us to use alternate interior angles to say that S and U are congruent. We also could have said that T and R are congruent because of alternate interior angles. So once we had that, now we have two angles being similar. So triangle SVR is similar to UVT by the angle similarity postulate. And then example 3, very similar to the ones above. Again, they want us to show that the triangles are similar and write the similarity statement. So in this case, they gave us F, G, and H. All those angles are congruent to each other. And then in triangle RQS, each of those angles are congruent to each other. So they're both equiangular triangles, which also means that they're equilateral. And in any equilateral, all the angles measure 60 degrees. So I know angle F would be congruent to Q, and H congruent to S, G congruent to R. Doesn't matter how I match these up because they're equilateral, equiangular triangles. They're automatically similar. So I could just say triangle FGH is similar to QRS. If I would have said triangle HFG, then I could have said triangle SQR. In 2, we're trying to show that CDF is similar to triangle DEF. So CDF here on the left, DEF here on the right. In CDF, I have a 90-degree angle and 32 degrees. So I could figure out my missing measure here for angle CDF at the top by doing 180 minus the other 2 degrees in that triangle. So I know angle CDF is 58 degrees. So that tells me angle CDF is congruent to angle DEF down here of 58 degrees on the other. Then I know angle CFD, my right angle here, and angle DFE, a right angle here, are congruent. All right angles are congruent. So I have my 2 sets of angles. So now I need to write my similarity statement. So if I start with C on this one, it corresponds with D on this one. So if I said this is triangle CDF, I'd have to start with the D on this one, and that would be triangle DEF. So you need to make sure that the letters that they correspond with are in the same spot. And we get down to examples 4 and 5, our last 2 for this lesson. In example 4, it's a word problem. And as always, I'd recommend drawing a diagram of the situation, which you can see below in my 2 triangles. It tells us a flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that's 40 inches long. How tall is the flagpole to the nearest foot? Now remember, similar triangles are proportional. So in this case, I'm going to use a proportion. So I drew my 2 scenarios. We have our flagpole here, which we're assuming is perpendicular to the ground. So it's a right triangle. So our flagpole and the ground, we knew the shadow was 50 feet. So here's our shadow length. We're trying to figure out how tall the flagpole is. Now, the key is when it says a woman nearby at the same time. So that tells us the sun in the sky is at the same point. So this angle on this triangle is congruent to this angle. And we're assuming the woman is standing upright. So we have a 90-degree angle. So we know we have similar triangles. Now we knew the woman's shadow was 40 inches. Her height, 5 feet 4 inches. If we convert that, it's 64 inches. So now I want to set up my proportion. If I'm trying to figure out x on this triangle, it corresponds with this side of 64 inches. So x over 64. Then on this one, 50 feet, length of the shadow there, over the woman's shadow of 40 inches. So on top, I have flag height, flag shadow. On bottom, woman height, woman shadow. So now we're going to cross multiply and divide. So in this case, 64 times 50 divided by 40 gives us a value of x being 80. So that tells me that my flagpole was 80 feet tall. And then in example 5, we have two parts, A and B. Part A, what if a child who is 58 inches tall is standing next to the woman in the previous example? How long is the child's shadow? So in this case, we're using the woman's information from up here, 64 inches tall, 40-inch shadow. So if we look at our setup, what we want to look at is a woman, 58 inches tall. So I put my woman on top, 58 inches, her height. Or child on top, child on top, meaning woman measurements are on bottom. We could have done woman on top, then the child would have to be on bottom on both sides. So in this case, 58 inches, child's height, over woman's height of 64 inches, equals our unknown shadow length over the woman's shadow of 40 inches. Cross multiply 40 times 58, divide by the 64, and we know x is 36.25 inches. So the shadow's child would be 36.25 inches long. Now, for part B, it says you are standing in your backyard. You measure the lengths of the shadow cast by both you and a tree. They just want us to write the proportion showing how we could find the height of the tree. So we don't have the measurements, but we can set up our proportion in words. So again, doesn't matter if we put our height on top or the tree height, but if tree's on top on one side, then the tree shadow has to be on top on the other. If your height's on bottom on the one side, your shadow length has to be on bottom on the other. So our proportion would be tree height over your height equals length of the tree shadow over length of your shadow. And then for today's practice problems, you will find them attached in Google Classroom. Please, again, if it's a word scenario, make sure you do a drawing of the diagram to help you understand it. And again, if it is any of these angle-angle similarity pieces, it all comes back to postulate 22 and the rule right here.